Thank you so much. Thank you. It's an honor to be here. As you heard, I'm Holly Cummins. I work for Red Hat. I help build Quarkus. I'm a software engineer. Now, among you all, how many of you are developers, software engineers? Yay. How many of you are UX, UI, design? One. How many of you are project management? One. Product management? Yeah, there's been quite a lot of product management talks today. And how many of you are sort of managing techies? A few, yeah. So as I mentioned, I'm a developer, and this talk is very much from the perspective of a developer. But I'm hoping that for those of you who are managing developers, this will also be interesting to understand the tortured little minds of the people who are reporting to you. I loved in the previous talk when Kinga was talking about finding your sanctuary. For me, code is my sanctuary. I don't really work very often directly with clients anymore, but when I was a consultant, when I used to work directly with clients, sometimes I'd have a client meeting and they'd just be so stressful. And so what I would do is I would go and I would play with the code to calm down. But of course, sometimes the code does fight back. So it's not always a sanctuary. And the other day, now for those of you who are developers, how many of you are Java developers? Not many. Okay, so I've got a little bit of Java stuff in here. So I was doing something I helped build Quarkus. I was doing something terrible to the Quarkus class loader. And I got this exception, and it said, invalid magic. And at this point, I love being a developer. I was reconsidering my life choices. What do you do when the computer tells you invalid magic? At that point, honestly, you just give up. And the thing is, our industry, we're sort of used to things being magical now. But they didn't always have quite so much magic as we have now. It used to be a lot more manual to do computer programming. In fact, it used to be that it was actually physical, because you would have a physical card and you would have to put the physical calls in the physical card in order to get the computer to do what you wanted it to do. And then our industry moved on a little bit. We got to actual code, but it was pretty low level, this code. So I love coding. I'm not sure this is the code that sent the Apollo Explorer into space. I'm not sure I would want to write this code. But I do love that it's so appropriate to talk about Margaret Hamilton here, because part of the theme of this event is the heritage of women in computing. And women have an enormous heritage in computing, because in fact it used to be that programming was women's work. And the reason it was women's work was because it was seen as not quite as difficult as the hard stuff, like like hardware engineering. And it was actually Margaret Hamilton who invented the term software engineering, which I didn't know. And the reason she invented this term is because she had her team, and she thought, what we're doing is quite challenging. This is quite sophisticated. I'm going to call it software engineering. And all her colleagues who were doing the hardware engineering went, oh, that's so cute. You're not really an engineer. Don't worry, you're just playing with the code. And I'm still just playing with the code. And then we sort of, continued to progress, and computing went from something that was only used by a few people in very specialist fields to something that was more accessible to, well, some people. So this was the world's first computer that was probably not exactly a home computer that everybody had, but if you were a normal human being and you were a bit geeky, you could go out and you could buy this computer. And it was about $2,500 in today's money. So that's, if you think about it, that's not that different than the price of a top-of-the-line MacBook. So, this was something that was accessible. But it was $2,500 for that box. If you wanted to buy a keyboard and a monitor for your computer, that took the price up to about $25,000. So you could have a really nice car, or you could have a keyboard and a monitor. So most people chose to have the car and then no keyboard and monitor. And so the way you interacted with this is, I don't know if you can see, but there's loads of tiny little switches, and there's loads of tiny little lights, and you had to flip the switches to put in the program, and then you had to read the thing out of the lights. You could not write something like Slack on this. You were limited in the programs that you could do on this kind of computer just because the input and output was so painful. So you had the switches for the input, you had the switches for the light bulbs for the output. No. Out of curiosity, how many of you have ever used a computer like this? No hands. I have used a computer like this, not because I'm completely ancient, but because in university, we did a module where we started out on computers like this. And I think the reason they did it was just to make us appreciate everything else that we did for the rest of that term, because it was like, oh, this is so hard. But it's not as hard as having the input on the light bulbs. But, things did get better. So I'm a Java developer. I've been a Java developer for most of my career, although I do a bit of JavaScript as well. And, when you compare it to the little switches, Java is really easy and it's really powerful. But of course, we haven't stopped there. Our industry continues to evolve. And so now we've gone one level higher up the stack as well. So now we're in the era of AI. We're in the era of large language models. We're in the era of prompt engineering. And these things are pretty powerful. So a while ago, I was trying to do a little demo. So I, typed in that. And then I got all of that. And then I got more code. And then it gave me an explanation of the code. And then it gave me more code. It took me about 3 minutes of typing to get all of that, which would have taken me days otherwise. So our stack is pretty different than it was for Margaret Hamilton. What we have is, at the top, we have the application. That's what we've always had. That's the whole point of the whole thing. At the bottom, we have the actual physical computer, the transistors. Then we have machine codes. Then we have assembler. That's about where Margaret Hamilton was working. Then we have high-level languages. And then on top of that, we have libraries. And then on top of that, we have frameworks. And then now we have this new thing where we have the AI assistant as well, which is hopefully helping us. And as you go up this stack, it gets more and more abstract. In principle, more and more powerful. So this is awesome, right? Awesome time to be a developer. Well, we do still have some challenges. What's the biggest challenge that we have in software engineering? People. Yep. The problem is always people. No matter what the question is, the problem is people. And I noticed this the other day because Quarkus gives you some shortcuts, and so I made, a little video, and I posted it on Twitter with the video of, how you could get rid of some code if you were using Quarkus. So, instead of having that, it was just a tiny little bit less code. And I thought, this is cool. And so I posted it on Twitter, and I got this reply, which I wasn't expecting, which was horrible. Like, oh, I thought it was kind of nice. And then someone else replied, and I will show you this, because it says, if one is not able to write a simple code and depends on generated code, then he is not a developer. Notice that it's he, right? The assumption is already, that it's a he. And there's this idea that if you have something that is simpler to use and more abstract, the only possible reason you would want to do something that was more expressive and more powerful is because you're stupid. And so there's this idea, again, a little bit going back to the Margaret Hamilton thing, where there's this idea that if you were doing software, you must be stupider than people doing hardware. There's this idea that, if you're working at the framework level rather than, doing the bits one by hand, you must be stupider. To me, it means you're more efficient and use your time better, but what do I know? And this idea really is 100% gatekeeping. This is about making people feel bad because they're not like you. And I love this gate, by the way. This is the Arch of Hadrian in Athens. And they looked at it and they said, you know what, we need a gate. But this gate isn't quite gatey enough, so let's put a gate on top of our gate to make it the gatiest gate that we can get. And this is exactly what we're seeing, often with software engineering. And we have had this for the whole of our industry. So I mentioned about Margaret Hamilton, but people also used to say the exact same thing when Java was introduced and it really brought garbage-collected languages to the mainstream. There was a whole class of errors that it wasn't possible to make anymore. And did people say, this is a really good thing, programming is safer? No, people said, this was a thread of advice to a programmer. It said, avoid using any language that uses garbage collection. I like the quotes, garbage collection. Avoid using any language that uses garbage collection, memory management. It teaches bad habits and makes for lazy, sloppy engineers. So there's this idea that if you're not doing it the hard way, you don't deserve to be in our industry. And, this is annoying, but it is also misguided, and it leads to worse outcomes, both for the people who are being told they're stupid, but also for our industry as a whole. And we can see this because the garbage collection discussion, for a long time, it was kind of settled. All of the modern languages were garbage collected. But then Rust was introduced. And Rust is a really, excellent language. And one of the things that's interesting about it is it doesn't really have garbage collection, not the same way other languages did. And someone did an experiment. And they went and they added garbage collection to Rust. And they found that adding garbage collection to Rust meant that people were more able to finish a task. So they had sort of a little programming exercise. And for the people who were using garbage collection, they were more likely to complete the task in the time available. And those who did so, those who finished it, needed only a third as much time. So these crutches, that make us stupid, also make us really efficient so we can spend our time on other things. And so at this point in the conversation, usually it goes, okay, well, using these tools, it might make you faster, but it makes the code slower. This is sometimes true, but it is not always true. There are a lot of ways in which a modern language will actually perform better than doing things by hand in one of these low-level ways. And then people say, well, yeah, but it's about the control, you see. I really want to be able to do things exactly the way I want to do them, whether it's the best way or not. And I saw this with my little tweet about the logging, because what people eventually said basically was, well, I've given up control of this bit of my code to something else, and I don't like that. It kind of makes me feel icky, which is understandable. And again, this is something that we see all of the time. So who wants to talk about formatting? Okay, because we all know, right? You only have to say tabs and spaces and people start twitching. But programming is something that gets us more excited and more angry than anything else in our profession. And it is also one of the least important things any of us could be talking about. And I used to work in a team that did a lot of pair programming. And I love pair programming. I really recommend it. It is very important to rotate the pairs often so that if your pair is irritating, you're only with them for a day and you can just about keep a lid on the sanity. And I had one pair who was not my favorite person to pair program with. And one of the things he did that drove me absolutely mad was he insisted on formatting all of his code by hand. So we had it so that if you would save, it would just format it. But he wouldn't hit Control S. He'd be there going, space, 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 space. And I'd be like, because, this was at a time when it was not necessary to type space, 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 because the computer would do it for us. And the thing is, we were consultants. I don't know how much we earned an hour, but the client was paying hundreds of dollars an hour for our time, which was being spent going space, 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 when a computer could do it. So I did get a little bit frustrated. But the thing is, I tell this story of I was so annoyed. But so many of us do this. Even if we now let the computer do the formatting, we insist on setting the formatting exactly how we like, because, it needs to be the exact way. And a while ago in my team, we had a discussion about Go. Does anybody, any Go programmers here? A couple. I've done a little bit of Go. I didn't get along with it very well. But one of the things that I really loved about Go was that they have learned from the mistakes of previous languages. And they have this thing called Go format. If you type Go format, it formats the code. And so the formatting convention is built into the language. And it's so good because it means that all of the Go programmers have about 20% of their life back from the arguments that they're not having about how to format the code. And so we said, could we do something like that for our corner of the Java ecosystem? And we said, yeah, that's a really good idea. Let's do something like Go format, but let's make it configurable. This was to miss the point so completely. But we can laugh about it, but we all do it. We all get caught up in trying to control what we can control because we can't control the big things. Another thing people say as we move up the stack is that it gets less correct. This, I have to say, is sometimes true. If you go to ChatGPT, I think they've fixed it now, but for a while, if you went to ChatGPT and you said, what is the world record for crossing the English Channel entirely on foot? It would tell you the world record for crossing the English Channel entirely on foot is held by Christoph Handorf of Germany, who completed the crossing in 14 hours and 51 minutes on August 14th, 2020. So it is so completely wrong, but it sounds really quite believable, actually. And we see this with code as well, that quite often when you ask ChatGPT to give you code, it will be wrong, but it will give you such a good explanation that people will think it's correct, even though it's wrong. And I noticed this in my own work, because if you know what you're talking about, then all of a sudden it's really obvious that ChatGPT is wrong. And so I asked it, I mentioned, that I got all that code out of it really quickly. And I looked a little bit more closely at that code, and I realized it was wrong in every way. It had really missed some fundamental things about what made our design good. And it told us to do things that were not necessary. And so we do have to be quite cautious with some of these abstractions. And there was another problem with using ChatGPT to write my code, which is we have this idea that going up the stack will make things easier. Sometimes not. So to get those screenshots, I had to try 4 different prompts to get it to do something that was kind of close to what I wanted. And does anybody remember model-driven development? One person is nodding, and I wasn't expecting many of you to nod. Model-driven development was one of those things that about 20 years ago, everybody was talking about model-driven development, and it was going to be the next big thing. And then we realized that actually programming in pictures, it looks great when you do a demo, but if you want to actually do something that's non-trivial, it's really, really hard to do it through pictures. Words are great. Words are quite expressive. And we're seeing a little bit the same thing sometimes with things like GitHub Copilot, that sometimes to get what you want, you have to write such a detailed comment in English that actually it would have been easier to just write the code because code's really well tuned to being code. And so we see with low code and certainly with model-driven development and with generative AI, I think what we're seeing is that these things, they look really great in demos, but they're hard to maintain. And if the problem is a new one, if the problem is something that we haven't seen a lot before, it can't copy and paste the answer off the internet. And so it tends to do pretty badly. So I think the jury's still out on whether going up the stack always makes you faster as a developer. But there is one thing that going up the stack does do, which is as you go up the stack, the number of things that you have to hold in your head goes up and up and up. And we can see this when we look at, again, like the choices that Margaret Hamilton might have had to make as a programmer. They were pretty limited. So in 1963, if you wanted to choose a programming language, you had a choice between Fortran, Algol, COBOL, and Lisp. In 2023, you have a choice between Python, C, C++, Java, C#, JavaScript, Visual Basic, PHP, SQL, and then you can go on. You could do it in assembly, you could do it in Go, you could do it in Scratch, you could do it in Pascal, you could do it in MATLAB, you could do it in Swift, you could do it in Fortran still, you could do it in R, you could do it in Kotlin, you could do it in Ruby, you could do it in Rust. And this is a lot of decisions to make, and you haven't even started programming at all yet. All you've done is just try and figure out how you're going to do the problem. And then, of course, that's just choosing the language. And it gets worse, because then you need to choose some libraries. So if, for example, if you're using JavaScript, you go to the NPM registry to find the libraries that are going to help you. And you sift through 1.3 million libraries to find the one that you need. Actually, that's not true. I think this was the data maybe from 2020 or so. It is now 2 million libraries. And then you need something to help you hold all of these libraries together. So you need a framework. And then someone somewhere at the C-level is saying, you know what? We need to be cloud native as a business. So then you go to the Cloud Native Computing Foundation landscape to try and understand what stack you should use. And it really is basically like this, just to try and...
Why did they think so?
I think someone didn't actually do it. I think they just made the picture, but it's so good, isn't it? It's still needed, yeah. And then we have another problem, because someone else in management has said, you know what? I know you were doing a good job at your job, but your job is now bigger because we need to shift left. So you did always have responsibility for the top bit of the stack, but now you also have responsibility for quality, which hopefully is a good thing. Hopefully you already had responsibility for quality. And you need to have responsibility for security, at which point you go, oh no, please no. And you need to have responsibility for observability. And you need to have responsibility for operations. And you need to have responsibility for usability. And then, really the cloud bills are pretty large, so you really should start taking some accountability for that as well. And all of a sudden, this is a lot that you have to do. And there's really good technical reasons for all of these to be in the developer's job role, because it shortens the feedback cycles, it makes things work better. But for the developers, it is a lot to hold in our little heads. And so it can lead to a bit of an overwhelm, because in 2024, it's not enough just to, do the apps that was our job. We also need to do the ops. And then if you're doing the apps and the ops, then that's the DevOps. And then, we need to not leave out security. So then we've got the DevSecOps. And then, the business is kind of going, well, what about us? We're like the whole reason. So then we need to add in the DevBizOps. But then, of course, now we've just forgotten security again. So we have to add in the DevSecBizOps. And then FinOps, we mustn't forget the money, because that's the thing that makes it all go round. It's a lot. So what I would recommend is, instead of doing shift left, I would recommend shift down instead. This is an idea that I saw in an article from Google. And the idea is, let the platforms do the work. So rather than having all of this on our plate, shove it down into the platform. We still have to care about the things like usability. Platform can't really do that for us. But everything else, let the tools take care of it. It's what they're there for. And then that means that we hopefully have some time left and some headspace left to focus on the most important thing, which is the value. So that leaves us with some big questions about our industry. The first one is AI going to take our jobs? The answer to this one, I think, is easy. No. And this isn't just me going head in the sand, I'm so special, AI couldn't possibly replace me. There's some pretty good evidence for this. If you look at the number of professional developers in the world over time, back in around 1940, when we started doing computing, there was a tiny number of developers. And then we got more sophisticated. We added assembler, tiny number of developers, but going up. We switched to transistor networks. We introduced high-level languages, tiny number of developers, but going up. And then we got the libraries, numbers going up. Then we got the frameworks, the number of developers is going up. All of these things that make our jobs easier did not make our jobs go away. They make our jobs multiply. And so now that we have the AI coding assistants, I just don't see that trend really changing. And when the high-level languages were introduced, the things like the Fortran and the COBOL, people did worry that they would put programmers out of work. I think we can all agree with hindsight, Fortran did not put any developers out of work, except for maybe the ones who were really bad at Fortran. And, people worried that they would put them out of work, but they didn't. And that was that there's sort of another part of it too, which is that software is not going away. And in fact, the amount of software in the world is just increasing exponentially. And this is really different from some other industries that have been disrupted. Does anybody know what this is? It's a profession called a knocker-up. I don't know if you can imagine from the picture what the job is. What it is before the Industrial Revolution, you kind of got up when you got up, and it didn't really matter if you were 5 minutes late, like your farm animals weren't going to, stop working because you got up 5 minutes late. But when we had the Industrial Revolution and we switched to working in factories, it suddenly mattered a lot more that we turned up when we said we would turn up. And so there was a need to get up at a specific time to make sure that the factories were fully utilized for the whole 24 hours. But of course, people tend to not be very good at waking up. And they particularly tend to not be very good at waking up at an exact time. So there was a job called a knocker-up, which was basically a human alarm clock. They would have a big stick, or sometimes they would use like a pea shooter or something like that, and they would go around and they would knock on people's windows. And I only learned about this when I was writing this talk, but apparently in some parts of England, the knocker-up stayed as a profession until, I think, like the 1960s. Like, really quite recently, we used to have human alarm clocks. And of course, now we don't even really have alarm clocks at all because we have mobile phones. So I remember carrying a physical clock with me when I traveled because I didn't have a phone. And now, of course, that's just a thing that doesn't exist. But the thing about a knocker-up is there is a finite demand to be woken up. It is only paid employees who need to be woken up. So if you're something like, I know we've been talking a lot about, career breaks and that kind of thing. If you are at home with a child, you do not need to pay someone to come and wake you up because you have a human alarm clock in your house who's going to wake you up at 6 a.m, whether you want it or not. So it's a very limited pool of the population who need an external service to wake them up. But the other thing is that nobody needs to be woken up more than once a day, right? Like once you have been woken up, unless you hit snooze, which happened to me today, and then I did need to be woken up a second time. But normally, you only need to be woken up once, right? Like, I don't need to be woken up at 1 p.m. So we have this really finite demand. Whereas with software, the more software we have, the more software we want. Software creates demand for software. So we have, we start off with the software to do stuff, and then we need the software to do more stuff. And then we need the software to bypass the advertisements on the software because the YouTube ads are annoying. But then we need, there's the arms race. So then you need the software to bypass the software that's bypassing the adverts. And then you need software to monitor the software, which is where some of the DevOps stuff comes in. And then you need software to debug the software. And then you need software to manage the software, which is where some of the cloud native stuff comes in. And then you need software to write the software, which is a little bit where we're going with some of the large language models. And then you need software to manage the software that wrote the software because it wasn't very good. And then you need software to try and avoid Skynet because at this point, all of a sudden it's getting a little bit alarming. And then you need software to tell people about the software because our cognitive load is so much that we can't actually understand all of the software. And then you need software to work out the meaning of life. And then you need software to gamify software. And this can go on forever, right? There is not an end to the demand for software, unlike waking up in the morning. So yeah, software is not going away. That doesn't mean our jobs won't change. So I think the productivity expectation for us will be higher. Just like when compilers were introduced, you couldn't say, well, compilers aren't taking my job, so it's okay for me to continue writing web applications in assembler. I'll get your web application finished in 5 years, right? Like that doesn't work. You have to take advantage of the productivity tools that are available to you, even if those productivity tools don't always do quite the right thing. So I think we probably will be in a situation where we end up spending more time trying to debug the generated code that was supposed to save us time. And we can kind of see this already. So GitHub did some research, and they found that Copilot users accepted 30% of its suggestions. They said this was a good thing, but you can flip this round and you can say 70% of the suggestions Copilot made were so bad, the user didn't take them. But I also think this is interesting because Copilot produced 40% of the code base, even though 70% of the time it didn't know what it was talking about. So I think this tells you that the information density of the code base produced by Copilot is probably pretty low. And you can see this if you use it because you get things like comments for your getters and setters. They don't need comments. The comment is just noise, but it makes it look like it was productive. And there is, because of this, among people using these kind of tools, there is evidence that the code quality is going down. And again, this is something that I see when I ask it to do things. It produces so much code, and I'm so impressed. And I'm like, wow, it would have taken me hours to type all this out. But the whole point is, I wouldn't have typed all it out because it's not necessary code. And so the way that these systems are trained and the mathematical models behind them tend to reward producing a lot of words. And our industry learned a long time ago that if you measure programmers by the lines of code, you get something really, really bad out the other side. I think we need to do the same thing now for how we train our large language models to say, let's sometimes optimize for something really short rather than optimizing for the flabbiest, wordiest, verbiest code we could get. And there's another more subtle thing as well, which is if code is so predictable that an AI can generate it, maybe this code shouldn't even be there. So I think these tools can actually be really good at showing us places where the code wasn't necessary. We had the model wrong. We made people do too much typing. And the reason we know this is because the AI could do it instead of needing a human to do it. So is it inevitable that things get better in our industry? Overall, I think we have this picture where, with a few exceptions, things are getting better. We can't take this progress for granted. A bit like the world as a whole, we go forwards, but not always. So in 1995, we had Java Java was great. In 1999, we had Enterprise Java Beans. Now, I know none of you have used Enterprise Java Beans because I didn't hear any screams when I put this slide up. Enterprise Java Beans are quite upsetting to those who had to live through them. And, we didn't necessarily learn as an industry from this because now we have YAML. And it was supposed to make things better. It really didn't. And so again, we do need as an industry to be learning from these mistakes. And we need to keep that focus all the time on the design and design to make things easy. Minimize the opportunity for error. Minimize how much crap people need to type to use your stuff. Minimize duplication of information and try and maximize expressiveness. That's what we want to be doing as, as anybody, but as developers, we want to be expressing ourselves. So let people do that without having to wade through mountains of boilerplate. And unfortunately, in order to do all of this, there is one extra step, which I hate to put up because this is the hardest bit, but we do need to talk to people, unfortunately. And if we see that people are able to save time using our tool by using AI, this tells us we got it wrong. And so let's challenge these assumptions about how things have always been done. So it used to be that you always had to be, when you were working, you had to hit Control-S all the time. Now you don't. There's all of these assumptions that we can just say, what if people didn't have to do this? So with my product, for example, with Quarkus, when people are developing, they don't want to configure a database. No one in development ever wants to configure a database. And we worked out we could just not have them not do it. We could do it for them. It's only in development. It doesn't matter. And so if you do nothing, we do the right thing for you. There is an interesting aspect of this, which is sometimes people get really confused by this. And I think this is a sort of a true for design in general, that if you make things so much easier than they were before, sometimes people will work really hard to do things the hard way. And because they're not supposed to do it the hard way, it's extra hard to do it the hard way. And so then we've made the hard way twice as hard by providing an easy way. So we do need to be cautious. But I think overall, this is where we have to be going as an industry. So with that, I will leave you with some key points. The first is abstraction is good. If anybody tells you it's not, they are gatekeeping. Shift down to make shifting left easier. Coding assistants are really good at typing. It remains to be seen beyond that what they're good at. Eliminate boilerplate, challenge assumptions, do things differently. You have the power to do that. And in general, as a developer, this is such a great job. And as a developer, we have so much power and we're so lucky in our careers. And so I would really encourage anybody to become a developer. It is a great job. And with that, thank you very much and enjoy the weekend.